Okay, so on behalf of the host chapter, the INCOSE Three Rivers chapter, welcome to our third session on Agile MBSE in the Agile MBSE Lunch and Learn series with Bruce Douglas. This session is going to focus on engineering agile requirements, epics, use cases, and user stories. This is one of the topics that I've been the most excited about out of the series. Bruce is really going to roll up his sleeves and get in and show us how to help decompose epics and some very useful patterns and tactics that we can apply. So this session is also being sponsored by the Smith & Nephew Robotics franchise. So thank you for that sponsorship. So the Agile MBSE Lunch and Learn series has 8 talks in it, and we've been sticking to kind of a theme series where the first couple were on agile modeling, what is modeling, some intro to Agile MBSE. The next couple theme talks are really going to shift the use cases and requirements. Then in November, December, we're going to shift to like ICDs and handoffs. And then January, February, we'll be testing and patterns. We also have been working on a survey that we're going to send out to kind of ask you all what you're interested in, and maybe we can pivot around some of the later topics and bring in some talks that the people are more interested in. We do have our next session locked in, so improving system requirements with use cases will be on November 3rd, and then we're gonna shift the cadence a little bit, and we're gonna go with November 22nd, which is where we're gonna talk about model-based interface control documents. So those are our next two talks, and we will be opening up a registration very shortly. So the series is it's a lot of work, it's a lot of coordination, and there's been funding required. So I'd also like to thank our organizing and sponsoring chapters, the Chicagoland chapter, the Three Rivers chapter, the Heartland chapter, the Michigan chapter, the Wright Brothers chapter, and the Canada chapter. Those are the 6 chapters that have really banded together to bring this Lunch and Learn series for y'all. So who is INCOSE? Well, INCOSE stands for the International Council on Systems Engineering, and it's a not-for-profit membership organization founded to develop and disseminate the transdisciplinary principles and practices that enable the realization of successful systems. So we're a basically volunteer organization that's set up to really strengthen and bolster the systems engineering process and systems thinking and systematic methods and development practices. So we were founded in 1990. We have 18,000 plus members, 74 chapters, 35 countries, and 55 working groups. There's also 3,500 certified systems engineering professionals out there. So for more information, please go to the INCOSE website at www.incose.org and check us out. INCOSE is made up of 3 sectors. There's the Asia-Oceania sector, the EMEA sector, and the Americas sector. The Americas sector has 46 chapters in 5 different regions. And we are, the 6 chapters here that are putting on this Lunch and Learn series are from the Great Lakes and North Central region. That's made up of the North Star, the Chicagoland, the Heartland, the Midwest Gateway, the Great Plains, the Crossroads of America, the Wright Brothers, Three Rivers, Cleveland, Northern Ohio, Finger Lakes, Michigan, and Canada chapters. So we're pretty diverse in our location, and with us being virtual due to the pandemic, we've all kind of banded together, and we can all participate in other chapters, talks, and things. So I recommend you check out our website and check out these different chapters on the INCOSE website and see what they have going on. In addition to this Lunch and Learn series, we also have other things going on in the region that might be of interest. INCOSE does have a corporate advisory board that's made up of member organizations that helps guide our direction. It's made up of government, industry, and academia members. And this is a list of all the different 119 organizations There's organizations like NASA on here, Boeing, Ford, GM, universities like Johns Hopkins, and you have also some national labs like Idaho National Lab. If your company is a corporate CAB member, you can sign up for an associate member for free by going to the INCOSE.org website. You've got to use your work email address. I've gotten some questions about how do you actually do that. I'll post a link in the chat that has 6 or 7 slides that just walk you through how to go, how to sign up, and how to get an associate member. There are also 55 working groups that INCOSE sponsors, and these vary from groundbreaking methods of development in the areas of like MBSE and system of systems, down to more foundational things like requirements, and even some domain specific applications of systems engineering, like the healthcare working. So I recommend you go to the website and check these out. You can, once you're a member, you can go and join and get information on what they're up to, go see what talks they have going on, and also participate in some of the local conferences that they do. So for membership and more information, please go to INCOSE.org. We are a volunteer organization, so we are always looking for help to organize talks, participate in some of our planning sessions, and really want to hear what you're interested in. We sent out a survey to the region. That's kind of what led us to bring this Lunch and Learn series together. So please log on to the website, send us an email if there's topics you're interested in, or if you're interested in getting involved. As every session, we're going to give out a free book to the winner. They'll be randomly drawn at the end, and the last session's winner was Shelly Higgins from California. She's a principal systems engineer from Raytheon, and she's also a certified systems engineering professional and a member of the Los Angeles chapter. So congratulations, Shelly. So the book prize rules again. It's an autographed book from Brice. It's a random draw at the end of each section, and you must be present. So without further ado, Dr. Brice Powel Douglas has deep and broad expertise from over 40 years of experience, specializing in both model-based systems engineering and model-driven development for embedded software for safety critical systems. He's developed systems in a number of subject domains, including aerospace, defense, medical, automotive, and telecommunications. He's a co-author of the UML and SysML standards, and is the author of over 7,000 book pages from a number of technical books, including Agile Model-Based Systems Engineering Cookbook, Agile Systems Engineering, the Harmony MBSE Design Book, Real-Time UML Workshop for Embedded Systems, Real-Time Design Patterns, Doing Hard Time, Real-Time Agility, and Design Patterns for Embedded Systems in C. He's formerly the Chief Evangelist at IBM and currently the Senior Principal Systems Engineer at the MITRE Corporation. So welcome, Brice. And with that, the virtual floor is yours, sir.
All right, so let me grab control here. There we go. So welcome, everybody. Today, what I want to talk about in this particular Lunch and Learn is epics, user stories, and use cases. In this lecture, we'll talk about 4 primary questions. The first of these is, so what's a user story? Because that's a national thing. How to represent it in SysML. What's an epic and how to represent that in SysML? What's the use case and how does it relate to user stories and epics? And then how do all these things relate to requirements? We won't in this lecture talk at all about how to analyze those things for coverage of the requirements, complete with the requirements, corrections of the requirements. We will talk about that actually in the next lunch and learn. We talk about use case analysis or functional analysis. In this one, we just want to talk about what are these concepts, how are they interrelated, how do we do it in MBSE in general. So big picture, we've got a time frame of months, multiple iterations. An epic, is a coherent set of features, use cases, capabilities of a system at a strategic level. So it's big, can't be done in a single iteration. There are a couple different kinds of epics. You have what are called business epics, which are kind of functionality provided. And you've got technical epics where you have things like reduction of technical debt, architectural concerns. Well, we talked a bit about architecture before in the previous session. I'll talk more about it again also later in other lunch and learns. But those are called technical epics. They don't really add directly perceivable value to stakeholders, but they kind of under the covers provide infrastructure to do so. So epics are big things done for strategic initiatives or strategic guidance of a system. Next step down in time is it's kind of single iteration, and it's typically 1 to 4 weeks. We have a couple of concepts here. One is a feature. Automotive systems that I've worked with, they often in terms of things automotive features, vehicle features. This is kind of the scope. A feature is something you might do in an iteration. A chunk of functionality to deliver some business values. I can control, my seats in my automobile. Up, down, left, right. Turn on heating. Those sorts of things would be considered features. Use cases is I'll talk more about this, but it's kind of a usage-centric capability of a system. So it's really similar to a feature. And it consists of a set of possible sequences of interactions, all of which tie ultimately down to requirements. And within an iteration, depending upon the size of your team, you might do a few use cases. One aircraft design we did in Canada, we did our cadence was about 7 use cases per iteration. Depends on the size of the team and how big use cases are exactly, and those are topics we'll talk about here. But the scope of it is an iteration. By the time you get done with iteration, you've achieved 1 or more use cases. Within the kind of day time frame, or days, small number of days. So this is smaller than an iteration. We've got work items. Those are, tasks that you as a user, as a worker, get to perform to achieve the mission or the goals of the iteration that are put into your backlog. Iterations. This is a relatively small unit of work. You've got a user story, which is if you will, kind of a large scale requirement. Again, a usage-centric, but small, singular focus capability around a single interaction, whereas a use case is around multiple interactions. The user story is around a single interaction of normally think about it with one actor, but it could be multiple actors with respect to the system to achieve some usage goal. Of the same size and scope is what we call a scenario. A scenario represents, again, a single interaction, typically with multiple actors, and the use case as they coordinate the interactions to achieve the goals of using the system. A use case, as we'll see, contains multiple user stories and or scenarios, because I consider user stories and scenarios roughly equivalent. Now, this is not the only way you could think about this, but it's a way I found effective in my own practice. And then much smaller than iteration, kind of at the hours time frame, we've got individual tasks. These are not things you would schedule. We're going to do this task, do that task, but they're part of things which might be considered to be schedulable tasks. It's a technical work that you perform to achieve a particular such as part of a task to achieve to do a user story. We're going to, do this bit of the model, and then another task might be to execute the model, test the model. Another bit might be documented. All those things together result in the user story. So these are on that. The same kind of time frame. Then we've got requirements. A single requirement. So user stories and scenarios represent multiple requirements. And a use case represents multiple use cases or scenarios. That's kind of the main story, I guess, of today. But that's kind of how I think about classifying in terms of timescale. These different things, these different concepts like epic, use case, user story, and requirement. So what I do in my practice is I model both epics and user stories as a stereotype of use cases. They're both stereotype of use case. And that's what's shown down at the bottom down here, where we've got epic as a stereotype of use case. In this case, I show an iconic representation. This is a Cameo screenshot. And the name of this particular epic is surgical ventilation. And we see kind of a standard form that I use to describe an epic. The name of the epic, its business goals, you as a business, the purpose, which is the value to the stakeholders, the needs addressed, the target groups of our customer base that are being addressed here, as well as potentially product lines. This is not uncommon to take an epic and install it in multiple products within a product line. And the nice thing about Cameo is you can expose those on the diagram. That's actually a nice feature of Cameo. Now, an epic here, stereotype of use case, has relationship to use cases. Collectively, these are bits of the epic. So in this case, for surgical ventilation, we want to be able to mix gases, oxygen, helium, air, nitrogen, so on. We wanted to monitor device health, do both power on self-test and ongoing built-in tests or bits. We want to scavenge carbon dioxide. We want to monitor patient parameters like SpO2, which is partial pressure of oxygen, non-invasive blood pressure, a heart rate, maybe temperature, and another kind of patient parameters. So surgical ventilation consists of all of these. And these use cases then would be delivered possibly in different iterations, but each one we deliver in an iteration. So if these are all in different iterations, this would then take 4 iterations to complete. And that's not uncommon. We see that a user story is also a stereotype of use case, and it has a tag value, an attribute of the stereotype called story, and we can actually expose stories here. That's what I've done here. I've also shown it as an icon. So we've got, for mixed gases, stories like deliver oxygen only, deliver air only, deliver a valid gas mixture, and refuse an hypoxic gas mixture. So something which is less than 21% oxygen or 19% in Canada for some reason. And there's a story is a string, and this is the typical format, canonical form for a story. As a physician, I want to deliver 100% oxygen with a certain flow rate to keep my patient alive during the medical procedure. That's kind of a typical user story that you might see. And we can expose those graphically on the diagram if we want to. This is, as you can see, a use case diagram, right? You see over the corner. So this is just an example of how you might do such a thing. And you can do this with, all of the current common tools. In this particular lecture, we've got some screen captures from Cameo and some from Rhapsody. So let's talk about use cases. We've seen these kind of descriptions that we have for epics. and the user story, what about use cases? A basic rule that I implement on all my projects, every important model element must have useful and meaningful description. And every modeling project should have a modeling guidelines document describes what we're going to do for this project or that project. The common form I use for use cases for description is this. So I give the name of the use case, its purpose, which is again the value to the stakeholder, a description of what the use case means by maybe how it works, but it's a kind of a high level just description of it. And then preconditions, what's true before this capability is performed, post conditions, what's true after the capability is done, and invariance, what assumptions am I making? So for example, here we've got a use case called navigate, and we see it associates to the actors, the inertial nav system, the navigator, which is a human operator, and then a GPS constellation. And this is my navigate use case. And we see its purpose is the air vehicle to navigate the airspace under manual automatic flight modes. Description is you get position from either the internal inertial nav or GPS, or some combination of the two. And given position information determines velocity and acceleration with a 9-degree of freedom model. Preconditions, we've initialized the system, it's passed self-test, and I can see at least 4 GPS satellites. Post conditions, well, it determines position, speed, and acceleration. It reports them to the navigator, or it might detect that there are errors, like my GPS antenna has fallen off the aircraft, or my INS has a fault. It reports those faults to the navigator. So it may not be able to achieve, but if it doesn't achieve, then it should do this instead. So those are post conditions. And invariants are, there's always at least 4 GPS satellites visible, and power is continuously applied. There's always some sort of assumptions that are being made, and it's good to be explicit about those. If I have this for all of my use cases, then I can reason about what does this capability mean, and I can detail the requirements, understand what's meant for my functional analysis, which again, we'll talk about how to do functional analysis in the next Launch and Learn. So let's talk a bit more about what a use case actually is. It's an operational capability of a system. So it's the capability from a usage-centric perspective, where a system connects to multiple actors shown as associations to the use case, which means that they exchange messages, either from the actor to the system, performing the capability, or from the system back to the actor, or possibly both. It's a way of organizing our requirements around capabilities. That's really what it is. Now, normally, if you ever have a use case with 1 requirement, it's a bad use case. You've over decomposed the problem. So you typically have minimum 10, maximum about 100 requirements. That's pretty common. If you've got a use case with 5,000 requirements, again, not very useful. You need to decompose it into workable things. It's a way of, the reason why we do this is because it allows us to reason about the requirements, to look at, do I have a good set of requirements? Have I understood all of the capabilities the system needs to do? Do you understand each individual capability well enough so that I can then specify what my design or architecture should do? That's kind of the purpose. So have 10 to 100 requirements. If I talk about user stories or scenarios, anywhere from at least 3 up to a maximum of maybe 20, 25 interactions to support that. And for most systems, you'll have anywhere from a few to a few dozen use cases. We'll talk about use case size in just a little bit. These can be done for any kinds of requirements, whether they're at the stakeholder level, system level, subsystem level, or even individual, what I call facets. A facet, we talk about this more on the ICD, and the handoff is where we really talk about it in more detail. A facet is a contribution of a specific engineering discipline to the overall system capability. So they have a software facet, electronics facet, mechanical facet, hydraulics facet, and so on. So for any kind of a facet or stakeholder needs or system requirements, subsystem requirements, and so on. So you can do those at different levels. A use case should return a value to at least one actor. If it's all inside the system and is not exposed in any way across the system boundary, it's not a use case. It's not externally visible usage-centric capability, kind of by definition, right? So it might be part of your design, and part of a leading kind of failure mode for people using use cases is trying to use use cases to do design. It's just not a good idea. Certainly design is important. I'm all in favor of design, but use cases are not a way of representing design. And if you try to do so, you'll end up with bad designs. So don't do that. So that means it should not reveal or imply internal structure, representation, or technologies. That's not the purpose. The purpose is to talk about needs, requirements. Use cases should be considered independent with other use cases and can be concurrent. So while I'm, think about my medical system, while I'm delivering gas to the patient, keeping him alive, I can also run continuous built-in tests. Right? That's okay. Now, if I want to constrain it and say this happens independent of this, you can't do both of these things, that's okay. That's another requirement, which then you put into those capabilities. You can't do this while you're doing that. You can't run the microwave while you've got the door open. You can't do that. And you're cleaning the microwave, can't be doing both at the same time. You can't be cooking food in your oven while you're cleaning the oven. That's not what it does. And you constrain these with various functional and quality of service requirements. So a functional requirement is like a verb, system shall do this thing. A quality of service requirement is an adverb, how well you're going to do that thing. Could be latency, worst case performance, bandwidth capacity, safety, reliability, all kinds of ilities, right? We call those quality of service requirements. And so the use case represents the collection of those around a capability, usage-centric capability of the system. So some recommendations. Use case names should be verb or verb phrase names. If it's a noun, in my experience, it's usually because you're trying to design something. So you should never have a name like system controller, because that's a thing, it's a noun. Control errors, control services, okay, manage your control services, that's a verb phrase. You have these control services like rudders and ailerons and wing flaps and so on. Okay, you're managing those, sure, that's a behavior. That's a capability. But a system that does that, like attitude management, that's the thing. Okay, so don't use nouns. You should really draw from the problem domain vocabulary to avoid overly specifying design. So rather than for in this particular case, we've got an intersection controller system which manages traffic for pedestrians and cars across the intersection. So rather than monitor the passive loop inductor impedance to look for a car arrival, we'd rather say detect that a car has arrived, because that's technology independent. It comes from the problem domain, not from the solution domain. Every use case should have a meaningful description. I gave you a canonical form that I like to use before that identifies in meaningful ways. What does it mean? So I understand if I have a requirement, is it included or not in that use case? From the actor's perspective, actors are shown as these kind of stick figures over here. There are expectations that the actor plays on are levies on the system capabilities. So an actor can work with many different use cases, but it wears a particular hat when it works with a specific use case. There's an expectation that the system provides certain features. You have to understand those to really grasp what the requirements are, because you're going to have this kind of usage-centric perspective. The user expects to do this or send this message. Now, it would also, I should mention, when I talk about actors, actors can be people. And in fact, the stick figure kind of implies that. But most actors in the world where I live are not humans. They're other systems. So, but there is expectations of interaction that have to be met. So what services the actor is expected to be performed by the system, as well as what services the system expects the actors to perform. I mean, for example, with my aircraft example, I'm expecting GPS to give me a time-based code from which I can determine position given multiple ephemeris data sets from different satellites. Right. So I mean, I have, as a system, I have expectations over what the actors I'm going to get from the actor. And this includes not only services, but also flows. Material flow, fluid flow, mass flow, energy flow, information flow. What are the flows in and out of the system? And functional requirements are really transformations, controller data transformations. So what controller data transformations are expected as a result of this capability of this use case? So there are various aspects of use cases that we have to consider. What are the services? So I think of a water heating system. Well, you know, we expect it to heat the water to some sort of set temperature, as well as perhaps to report the current water temperature. Flows in and out, the set temperature, I'm going to, set, I want to set to 90 degrees to 110 degrees, whatever temperature I want to set. Give me the measured temperature. If the temperature exceeds this either too high or too low value, alarm. Those are values that I expect to flow in or out of the system. What are the controller data transformations? Data, cold water flows in, hot water flows out. You also need to, as part of your quality of service requirements, specify precision, fidelity, and accuracy. So really quickly, precision is the degree of information with which something is represented. Accuracy is the conformance to a level of precision. And fidelity is the degree of control exercised over some control value, such as an input. So specify those things. Those are real requirements we need to capture. So in this case, you can think about, I want to set the temperature units of 0.5 degree centigrade, and I want to manage the output flow temperature within 0.1 degree centigrade. As well as you have latency, other kinds of performance requirements. Use case size. So not all use cases are exactly the same. Think of a small system like a cardiac pacemaker. Yes, I used to design those. Think like pace the heart, set pacing parameters, perform Holter monitoring, other sorts of things. You'll have a few hundred requirements. 6 to 24 use cases is pretty common for such a small kind of a system. For medium-sized systems, in this case, it's a patient ventilator. Yeah, I used to design those too. We've got a few hundred to a few thousand requirements. So we'll have, from 10 to 70 use cases typically. We'll have use cases like ventilate the patient, monitor vital signs, configure ventilation. So these will probably be a bit bigger than these small system use cases. Instead of having, 20 requirements, you might have 40 requirements, maybe. Large systems like a tomography scanner. Yes, I used to design those too. We might have control patient position as they go in and out of the rig, identify tumors, perform a scan, those sorts of capabilities of systems. So you've got, thousands of requirements, many thousands of requirements. At this point, you start having 6 to 24 high-level use cases, which means that there are high level and more detailed level use cases. So we have different levels of abstraction, typically 1 to 2 levels of abstraction. And you usually do this with includes relationships. So the larger scale use case includes a smaller scale use case. So that's include relationship used there. You might have, for a large system, 70 to 500 use cases. And finally, for what I call huge systems, we'll have tens of thousands to hundreds of thousands of requirements. 6 to 24, again, high level use cases, but multiple levels of decomposition, 3 to 5 levels now. And we might end up with 500 to over 1,000 use cases. So I'm doing things like the aircraft level. I'll end up with, pretty easily 1,000 use cases. The Boeing 727 is what, 200,000 requirements? So there's a bunch of requirements there that we mapped use cases, not all requirements mapped use cases. We're going to paint the plane green isn't a behavior, so it wouldn't be allocated to use case. It's just a property of the system. But other use cases like it can change color, which would be kind of cool, would be behaviors would be allocated to some sort of use case. So here we've got manage stores, control attitude, navigate aircraft, autopilot of the aircraft, manage the internal environments like air temperature and oxygen concentration and so on, pressure. Those are use cases you might find at an aircraft level, which might be further decomposed into smaller use cases as well. So that's how I think about managing this kind of use case size. And at some level, these use cases at the upper levels of abstraction, the high level use cases, are really too big to manage in a single iteration. So they'll be broken down into smaller use cases, or and those will be maybe further decomposed into multiple interactions or multiple user stories. So user stories from use cases. We're going to take the use case and identify small levels of singular interactions. You want to support small levels of functionality that meet a specific system user need that can be delivered in a few days of work. So again, smaller than a complete iteration. There's a canonical form for representing user stories. As a rule, I want feature for reason, or so that something happens. There's a pretty kind of standard form. And like I say, these are roughly equivalent to scenarios on sequence diagrams. And so you can choose to do this instead of a sequence diagram, I think. So take the use case in terms of procedure, take the use case, identify the different specific interactions that you want to represent. Cast each as a separate user story. Model use case story is a stereotype and capture the story. And it relates to its owning use case with the include relationship. If you want to think of, if you've done like a functional flow, a lot of system engineers like to start with an activity diagram of functional flow. A user story might be one of the paths through that activity flow. It's a single kind of interaction. You take each decision, singular decision, each branch point. That might be a particular user story. Now, at the end, when you've got all of the user stories, you want to make sure that every flow and every requirement is met somewhere. That you don't have any kind of extraneous free-floating requirements which are traced to by the use case, which are not accounted for by some user story. User stories are how you're going to develop the design to meet that particular set of requirements. So you want to make sure you don't have free-floating requirements which are not accounted for. You want to make sure you've handled exceptions, misuse, error cases, security penetrations, safety violations, all those kind of edge cases. You want to make sure you handle all those cases as well as part of your user stories. It might be separate user stories. When a pilot does something stupid, do this. right? And that can be part of the user story to add into your safety story. So this is a kind of a rhapsody view of something similar. We take our mixed gases use case, break it up into a set of user stories, deliver oxygen only, air only, valid mixture, refuse hypoflow, a flow there's not enough flow to meet the needs. Hypoxic mixture, not enough oxygen concentration to meet the needs, and also handle machine faults. What do you do if the intern is standing on the airflow tube from the oxygen supply? How do you detect it? What do you do about it? You know, whatever it is. And so there are stories associated here.
Can we ask a question now, or can we wait?
The best thing to do is to post in the chat, but go ahead since you brought it up.
Could you make a tie on how to develop the user stories in the context of the actual sprints? Because as a system engineer, one of the things I've been struggling with the software team is exactly to take that use case, but to apportion it, you know, because the software people are working in sprints, and basically at the end, that they finish a sprint from the user stories, we get to witness and basically sell it up. And that becomes very complicated to actually break down the use case and to write it into stories that are executed as sprint. And usually not only go sprint, but you know, the whole use case may not be totally sold off until several PIs later. So
okay, so quickly, let me address that. The sprint, which I've been calling an iteration, the mixed gases use case is done within that sprint. Okay.
Okay, so that clears it up. So you're saying use cases are done at the sprint level of granularity?
Correct. So this is your sprint. Now within the sprint, you might do all 6 of these user stories. Right? Could be different people, could be the same person working sequentially, doesn't matter. But in the scope of the sprint, we will deliver all 6 of these user stories because we deliver that use case. And that is the kind of size scoping that I'm recommending here.
Okay. So what's the higher level granularity from use case, the one that would map in a feature, which by definition you try to accomplish within a program increment, within PI?
Okay, so that was the PIs are typically organized at the epic level. So
From an
PI,
agile perspective, but what would be the systems engineering equivalent?
it's a high level use case, right? So an epic. Remember back to us. I don't want to get down this rabbit hole too deep, but an epic is at the PI level. Okay, so I want to provide an epic, a program. Now we're going to support surgical ventilation, not just bedside ventilation.
Actually, I thought a PI an epic spans PIs.
No, an epic
Features at the
spans
PI.
iterations. An epic spans iterations, but an epic scope is usually a single PI. Okay, a PI is multiple iterations. Typically, 6 is a pretty common number thrown out there for program increments in SAFe, right? So that's typically the same scope as an epic, right? Whoops, somehow I zoomed in. Not sure how that happened. There we go. All right. Okay, so let's get back. We do have, okay. So let's go ahead and continue now. So we do have stuff to talk about yet. And then here we see the user story then corresponds to some set of specific, shell statements or typical requirements. So many agilistas don't like to put in shell statements, don't like to have the requirements. But if you're ever doing safety critical systems, this is required for certification, or you will not be able to use the environment, use the system in your environment. You will not be certified for use if you don't provide textual requirements. Now, user stories are a great metaphor for building up the design, a user story at a time, but they need to relate down to individual requirements for certification needs, if nothing else. It also provides fine-grained detail what we mean by user story. So some guidelines. User stories focus on users. It's even in the name. Then we want to, again, avoid talk about internal design, but talk about as a user, I need this to happen. I don't care how it happens, what kind of hamsters you have running around in squirrel cages inside your system, but I need this to happen. And I want to have this kind of interaction from external black box perspective. These users really are not users per se, they're really more roles of their hats that users play when they're trying to achieve some goal of their own. So that's the persona. It's the hats that they wear, the roles that they play. Developing these collaboratively with the stakeholders and subject matter experts, as well as the developers and product owners, is really a good idea, because you want to make sure the designers understand it. You want to make sure the stakeholders' needs are being captured properly. And this should be precise enough. They say the general guidelines for stories is if it's complex, breaking up multiple stories. What I tend to do is complex, I might break it up into multiple stories, or I might go to scenarios, because scenarios using sequence diagrams are easier to capture more complex interactions. So if it's for simple, user stories are great. If it's a bit more complex, user stories begin to fail. I might want to move to an interaction explicitly with sequence diagrams and interactions and scenarios in that case. Start with your epics and use cases to understand the context of what you're trying to achieve in the larger scope. Understand the role that this user story plays within that scope. And for me, the scope is the epic is the big thing, that's the program increment size. The use case is the smaller thing, that's the sprint or iteration size. And the user story is a piece of that. Refine your stories as your understanding deepens, refactor the story and add more detail to it. Be clear about what it means to succeed. So I understand your acceptance criteria. I model these as stereotypes of use cases, as I mentioned before. It's not the only way to do it, but I find it a very useful way to do it. Don't rely solely on user stories, particularly for edge cases and for complex interactions and for precision and accuracy. User stories become awkward to express. And so while user stories are maybe a great way to have the conversation, usually they're not completely adequate in all cases. At least some of the time, you want to have other means for representing the details. And since it's a means for communication, one of the nice things about user stories is it's easy to collaborate with stakeholders who may be very non-technical. So you don't have to talk about the details internally of how you implement it. You can still talk about what are their needs. And user stories mean natural language, or an easy way to express that. Sequence diagrams, there's a bit of a learning curve to understand and express things in sequence diagrams versus just talking about it as user story. Scenarios are another thing that are, I think, at about the same level of abstraction as the scenario. So they're an alternative approach. So we decompose the use case into interactions, which are specific actor user system interactions that you'll capture, typically represented on sequence diagrams. So each one of these interactions is represented as a separate scenario on a sequence diagram. In SysML, that's what you have for representing interactions. So when you have a scenario, typically model that in a sequence diagram. Vertical lifelines, usually there are two kinds. You'll have the use case as a lifeline, and you'll have the actors as lifelines. And the flow, the directed lines between those lifelines represent messages, interactions between those. So if you've done a functional flow, again, a scenario is a singular path through that functional flow. So where you take a singular decision at all branch points. and represent that. And if you take other decisions, that's a different scenario, different sequence diagram. Every path in a functional flow should be represented in some sequence diagram somewhere to get what I call a minimal spanning set. I recommend you start with the sunny day or primary scenarios first. Everybody is, fat, dumb, and happy, and no exception conditions. But then later, you'll have to add those secondary scenarios, exceptions, error handling, fault paths, misuse paths, security violations, safety violations, and those other kinds of paths. And annotations and constraints for quality service requirements. So, if this has to happen before this, and that time frame must be less than 1 second. That's a requirement. Specify that. So when you're talking about completeness of your scenario set, and so your use case maybe traces to 50 requirements. Every requirement should trace to at least one message somewhere on some sequence diagram. That's the minimal set you have. You might want to trace it to a few if that's convenient or helps you understand the problem better, but at least one. You never want to have a case where you're done, but you have some requirements that aren't traced anywhere to some message in the sequence diagrams or your user stories. You have to get coverage. So here's an example. This is from a training course that I teach. We're an ATM system. We have use cases like get money, deposit money, verify customer, check balance. If you look at get money, what I do, and we'll talk about how to actually do the analysis later, I represented a structural context. So I've got a block that represents the use case. I've got blocks that represent all the actors, and there are technical reasons why I do that. We'll talk about that in the next Lunch and Learn. I've got interface blocks that describe the messages flows between these port pairs for the interactions. This provides what I call structural context for the use case analysis. And then we start building up these scenarios. So here I've got my lifelines. Here's my use case for get money, my actor for the customer, and the actor for the bank. And insert the card, we verify the customer, display the options. The customer then selects withdrawal. I want to withdraw money. And the system displays which account sets. They select a particular account. Then they say, I want to withdraw from that particular account. It says, well, how much? You enter the amount that you want to withdraw. Then it requests of the bank, they'd like to withdraw this much money. What's the current balance? We check the balance. If there's enough money, it comes back and says, sure, I'll go ahead and debit the account. Once it's debited, then I can dispense the money. As an ATM system, I decrement the amount of money I actually have physically present in the system. I do need to track that. I tell the user to remove the cash, and then I go back to select account withdrawal mode. From here, they can cancel and return the card. So that's a scenario. You can see there are lots of branch points. What happens if I can't read the card? What happens if they select something other than withdraw? What happens if they request an account that you don't have access to, you don't have permission to withdraw from? What happens if they try to withdraw too much money? What happens if the debit processing fails? Well, all those would be different scenarios, different interactions you have to address, different user stories if you want to do by user stories. And as we go through this, we can identify what the requirements are. So you might walk through, this is a pretty common thing that I do when I'm working with folks, with subject matter experts who are domain subject matter experts. I'll set something like this and walk through how they want the expected this interaction to unfold. And as I walk through this, I capture requirements corresponding to every one of these messages here. Every message here represents at least one requirement. So it could be that collectively, 3 messages represent a single requirement. That's okay, but every message traces to some requirement somewhere. It represents an entire requirement or some set of requirements or a part of a requirement. It's all traced together. If it represents something other than a requirement, it doesn't show up here. That's not the purpose. So as I walk through this with my stakeholders, I can identify the requirements of what they're saying, how they want the system to interact. That's one of the outcomes. If I'm not starting with a set of requirements, I can derive a set of requirements. Or I can start from the set of requirements and from that derive the scenario. And then go back to the stakeholder and say, this is how I'm interpreting what you're asking for. Is that right or not? And that's part of use case analysis, something we'll talk about in more detail. Again, next lunch and learn. Okay, some scenario recommendations. The key lifeline is really the use case. And some people prefer to use the system here, but really use case is fine. And it's more specific. I prefer to use the use case myself as the key lifeline. The other lifelines are the actors. Every scenario should have a description. And this is, remember we had a kind of standard form description for use cases. This is my standard form description for a scenario. Now, what's the related use case, purpose, description, preconditions, postconditions, and invariants. I don't need to repeat the use case scenario, preconditions, postconditions, and invariants. I get those, but it's a particular case as additional preconditions and postconditions and invariants. In this particular case, our starting condition is this, in addition to the normal starting conditions for the use case. To represent time, Todd, it's not a lifeline. Time is a message to self. And then when you have state-based behavior, which is pretty common, you remember back and we had on the scenario we just looked at, there are those rounded rectangles. Those are state invariants. As you can look at how the use case is going from state to state as the behavior unfolds during the performance of that capability. So remember I mentioned that we still often start off with a functional flow from which we can deduce scenarios. So if we look at here, there's some decision points here. We can follow one decision point where we take this branch, and this can result in a particular scenario. Now the Rhapsody tool has a built-in a toolkit called the Harmony SE toolkit that can generate this for you automatically. But it's really not that hard to walk through and do it by hand. But the Harmony toolkit does actually have an automation to create this. And in fact, this was created from this activity diagram in this case. So talking a bit about requirements, there's a number of ways you can classify a requirement. Requirement in SysML comes from a class in UML. One way to classify them is in terms of like the semantic kind, semantic content. And so we've got non-functional requirements, we've got functional requirements. There's two basic kinds. Functional requirements associate what I called quality of service requirements, which are a kind of non-functional requirement. Quality of service requirements can be performance requirements such as speed, latency, capacity, precision, and so on. Or it can be dependability requirement such as safety, reliability, or security. And there are other kinds of non-functional requirements such as certification, logistics, operational design requirements, maintainability requirements, and so on. There are other kinds of ways of classifying it. This is one way you can think of classifying requirements. An orthogonal way is to classify them by their context. Who cares about it? So we've got stakeholder context, the ultimate users. We've got the system requirement, which is the stakeholder has a need, needs to be satisfied. A system does things. Hopefully the things it does satisfies those needs. So system requirements are about what a system must do. And a stakeholder need is about what that stakeholder needs. Those are not the same thing, I want to point out. And then there's subsystem requirements, which you get system requirements typically decomposed and allocated into subsystems. And then you've got, as I mentioned before, engineering facet requirements like software, electronics, mechanical, and so on. So it's another way to classify requirements. Oops. So there's a kind of a canonical form for requirements. The system shall, followed by some sort of verb phrase. And then they talk about adjective flows or attributes with constraints under some conditions. That's sort of a canonical form. And that's similar to the canonical form for a user story, but a little bit more elaborate. So we can think about some examples here. I've kind of color-coded this to show what this looks like. For stakeholder requirement, the aircraft shall control roll, pitch, and yaw smoothly, whatever the heck smoothly means. Functional requirement talks about system shall maintain all three rotational axes of airframe stability when subject to steady winds. Functional quality of surge requirement adds, within 2 degrees of arc in the presence of gusts up to 40 kph. A parametric requirement, this is a requirement that you don't typically model with use case, but it's weighed no more than 30 kilograms and loaded with hydraulic fluid. It's just a system property, not so much a behavior. But the system shall have a maximum current draw at half an amp at 240 volts. And you might even have project quality of service, such as we want to reuse these components from some other design. So that's a requirement on the project to reuse a design because, well, reasons, right? Some business reasons you have. But they're not really related to the delivered functionality per se. So these are just some example requirements using that canonical form. There are a number of ways of representing requirements used in SysML. Requirements diagram, I don't use very much, but it is really good at showing relationships among elements. It's not a great view for reading the text. Requirements table is probably the most common because you can read the text very easily, and you can read lots and lots of requirements text very easily by just scrolling through the rows. Requirements matrix I use a lot for a variety of reasons, but a matrix, a table shows metadata, information, properties owned by the elements held in the table. A matrix shows relationships between sets of elements. And so I can look for trace relationships or allocate relationships or any derived relationships between different sets of elements. So I might have requirements use case to the system element, design, requirement to test case. There are all kinds of matrices I can build up to look to make sure I have adequate coverage, that every requirement is tested, every requirement is implemented in design somewhere, all the requirements use case are managed in scenarios, a variety of reasons I can use matrices. And the last topic here is talk about white box, black box. It's really important to understand what you can see at your given level of scope. And a big problem with coming up with requirements is that people don't adhere to the rules. They peer inside the design and say, oh, I know there's a reverse biasing diode here. But really, if you have a black box perspective, every level of abstraction, the thing on which I am levying requirements should be treated as a black box. And I can talk about the transformations performed by that black box, but not how they're performed. What their transformations are, yes. How they're performed, no. And that's what we call the black box perspective. The white box perspective means I can look inside and see the design and how things are performed. So requirements are always developed at a level of abstraction, whether it's stakeholder, system, subsystem, engineering facet, and so on. There's always some level of abstraction. Requirements should always be a black box at that level of abstraction. They should specify what transformations are needed and maybe how well they're performed, but not how they're actually done. That requires white box perspective. So just a little graph what that kind of schematically looks like. As a system of system context, we have some actors and our system of systems. System of systems contains internal systems which might connect to each other. And this is now first level down, system context. Then at the system context, I can talk about the system architecture. What are the set of subsystems inside there? And now I can talk about levying requirements on the individual subsystems because they're visible inside my perspective. One level up, I can't see the subsystems. I can't levy a requirement on a subsystem here because I can't see it. It's important to maintain that perspective when I'm specifying requirements. And then at the subsystem level, typically that's where I introduce my subsystem design. That's where I introduce the notion of engineering facets, software, electronics, mechanical, chemical, and so on. So depending upon at what level I'm working at, I'll identify different kinds of requirements to levy on different kinds of elements for that purpose. So that's a really brief introduction to epics, use cases, scenarios, user stories, and requirements. In the next session, I want to talk a bit about, so given I've got a use case and I've got some user stories and scenarios, how do I know they're good? How do I perform that analysis to find missing requirements and so on? How do I do that analysis? And but that's for a story for another time. So with this point, I'll give control back to Dan.
Thanks, Bruce. Seem to have lost my screen. Okay, so the winner for the book is Chris Stops. So Chris, we have your contact info, and we'll be sending an email, getting your email address to get that out to you. And yep, congratulations.
Thank you.
And let's go and take some questions that I have in the chat here. So all the way back on slide 10, Bruce, we got a couple questions around, you know, high level use case and use case versus epics. What's the difference between the high level use case and epics, and some of the SysML methods for modeling that. If you don't mind, you know, just talking to what's the difference about high level use cases versus epics. And then I think I'll ask Andrew. Andrew had a question that we might follow up your response with.
Okay, so high level use case is just use case that contains other use cases. It can either be concrete or abstract. By concrete, we mean that it has requirements directly allocated to it. By abstract, we mean it doesn't, that the requirements are allocated to the kind of part included use cases. Okay, so that's what I mean by abstract and concrete abstract use cases. So an epic can be considered just a special case of a high level use case. A high level use case could potentially be all done in one iteration. It has multiple use cases inside of it, but you know the team of people will all develop that high level use case within one iteration. So by definition, it's not an epic. But a high level use case, which you would split across multiple interactions or multiple iterations rather, would be considered an epic. So it's just a high level use case. It's just a kind of epic, but an epic is a high level use case which is not done in a single iteration, kind of by definition. So what were your other questions?
I guess ask mine. It was a little wordy, and I wasn't sure how to best to describe it, Dr. Douglas. But you know, on this diagram and others, you seem to, you know, all of these elements here are use cases, although they are stereotyped, and you kind of a heavy use of the include relationship to, it seems like, to kind of decompose these use cases. And I guess maybe my question is a two-parter. Number one, some others in, you know, just with the field of SysML have kind of warranted against using the include relationship to decompose use cases. So I was just kind of wondering, are you kind of suggesting a conflicting, or kind of going against that in this case? And maybe that's just because of stereotype, or if you could just kind of speak to that. And then also, would each of these use cases be related to some behavior or some requirement or some structural feature, or would only the leaf, I guess, use cases or the atomic use cases then be related to those requirements or other elements?
Okay, so I counted 3 questions there.
Okay.
Okay, so let's talk about
Apologize.
inclusion. There are 2 ways that humans manage complex things. Breadth and depth, okay? So breadth means I just add more things at the same pure level of abstraction, and depth means I decompose. And so I was saying you can't decompose because that's bad means that you can't do half of the reasoning that humans do. So I guess I'm arguing against that. Just on a first principles basis, decomposition is not the only tool you have in your toolkit, but it's a really important one. Just look at things at different levels of abstraction. That's what decomposition is, after all, whether it's a size abstraction or some other kind of abstraction. So yeah, in this case, I want to have a use case, for example, mixed gases. And I think, well, what are the primary, interactions supporting that? Well, maybe there are 100 requirements there. Well, that's an awful lot of things. What if I want to cluster them into, 10 kind of key ideas here, 10 interactions? Well, what is that relationship? Is really includes, right? Furthermore, includes relationship is what's available in SysML. So I am, even though that's abstractly I want to do decomposition. If I'm going to do decomposition of use cases, includes is what's provided in SysML. So I'm going to use what it provides rather than my own kind of relationship for that. Because includes is well defined. So if somebody wants to argue with me about there's a better way to do the same thing, let's have that conversation. But this works. I know it works because I've done it, but it's certainly not the only way to do it. Okay. So that was
Okay.
question. What was your other question?
That's perfect. Let's build on that, because there's another question that asks, in a complex product, system of systems, how do epics, use cases, and user stories relate to system, subsystem, and component requirements in the hierarchy of requirements? Can epics, use cases, and user stories be for systems and subsystems at each level of the hierarchy when a complex product is being decomposed? So I think what this question is really asking, Bruce, is can you line up that hierarchy to your systems hierarchy?
Absolutely. Look at it here. We've got a system of systems, right? So I've got an aircraft, I've got a tank, I've got a missile launcher, I've got a satellite, and I've got some radars. Okay, that's my system of systems. And a capability is I want to monitor airspace around the continental United States, let's say, right? Well, there we go. We've got a systems, kind of capability, which I might want to model as an epic or use case. It's some kind of functional thing, right? Functional structure. From that, I would say, well, what does that mean to my satellite? What does that mean to my aircraft? What does that mean to my radar? What does that mean to my JDOC system, to my Eastern Air Defense Sector? What does it mean to those things? So that, to my mind, is an inclusion, right? At the system of system level, we've got monitor airspace. And for the missile launcher, I've got, shoot at stuff we don't like in our airspace. For the satellite, we've got monitor airspace using optical visualization. For radar, we've got monitor limited area space with surface reflections by bouncing energy off of it, right? So those are all decompositions of the higher level need, which is the high level capability, which is monitor airspace. Now, for an aircraft, we've got a whole bunch of things that it does, and it would have this, I do visual identification of something in the airspace as one of its capabilities. It has a number of features underneath that. to perform that, some of which should be allocated to its internal radar, some of it to its communication system, some to its, maybe weapon systems, to its flight management system, to its FMS. So again, that's levels of decomposition, and you can trace an entire taxonomy of capabilities at increasing levels of detail as you go through your, system of systems, down to systems, down to your subsystems, down to your individual engineering facets. What does this mean for the software of my radar on my aircraft, right? All the way back up to on a monitor airspace, my capability of my system of systems. So to my mind, that's a complete chain. That is something that you, and all the reasoning at all those levels makes sense. Does that answer the question?
I think that is for me. Okay, back on slide 11. We get a question that says, I understand that user stories are focused on the user goals. What is the equivalent of user stories for stakeholder needs and how these relate with stakeholder requirements?
So user stories are it's a usage-centric, fine-grained, fine fidelity capability that are expressed from the perspective of the stakeholder. So I think they pretty directly correspond to a set of requirements, of stakeholder requirements. They less directly correspond to a set of system requirements of what the system actually does. Because some of the capabilities in a specific user story will be met by the user in the context using features of the system and go on in the user's brain. And some of them will be met by system functionality. System will present this information so the user can make a decision, but the user actually makes the decision, perhaps, right? So stakeholder needs is I need to be able to make a decision based on this information, for this purpose, right? And that's the user story. So user story then will include or trace to, if you want to use trace, that's fine. Trace to, I usually use trace to down to requirements. Trace to a number of stakeholder requirements for what that system must do. So I think user stories trace more directly to stakeholder requirements and the system requirements by their nature, because they are specified from the role perspective. As a user, I want this for this reason. Does that answer your question?
Yep, I think that covers it. Thank you. I have another question that says, can you share how SysML fits with SAFE? How SAFE suggests to compare and manage the rest of the artifacts which are not systems engineering specific or can all be in SysML?
I have a little bit of heartburn with SAFE, is the way it's expressed, in that SAFE has this little area called system engineering off in the upper left-hand corner of the SAFE lifecycle, where they talk about, there's system engineering going on, as if it was something to be done in a couple of days, and then the real work is all done down in the agile development teams. And that's not really my view of the world. That system engineering is an ongoing activity that takes months to perform, and in parallel or in sequence, software or development team activities go on to develop the pieces. But system engineering goes on in parallel with that. So I have a little bit of heartburn on how it's represented, because they don't explicitly say that, but it's implied as this kind of this, oh yeah, by the way, there's some system engineering goes on, and it's done in a day or two, and then the real work is done somewhere else. But system engineering is in fact real work. And that's some of the heartburn I have with the way SAFE represents system engineering activities. Now, it doesn't kind of mandate, doesn't explicitly say that, but it kind of implies that if you read it. And if you have a different opinion, I'm willing to hear your opinion on it. But I've been through the SAFE literature, and that's kind of my take home. It underplays the importance of system engineering for guidance of the overall engineering content, and really focuses really heavily, particularly in the software aspects, down in the Agile teams, not even the electronics or mechanical aspects. So some of it is where it comes from in its historical basis, but I think that it plays the role of system engineering in the overall process. So I'm not sure if that answers your question or not.
I think that does. I think that does. Okay, so I got another question. It says, can you give your view on similarities or differences between Capella MBSE / Acadia method versus Sysml Agile MBSE methods in this context?
I'm not really familiar with the Capella or Acadia tools. So I really can't, I'm sorry, I really can't speak to that.
Okay. Shelley also has a question, and she was asking, particularly interested in best practices for dovetailing user stories, use cases, and requirements when chunking your work for sprints. Is it better to break down work at hand by testable and/or demonstratable results, perhaps?
Oh, definitely. You know, at the end of the iteration, every iteration has what I call a mission statement, which includes functionality delivered, which runs on a specific platform. The platform tends to migrate in a standard way over time. Refactoring and technical work performed, risks reduced, right? So there's like 7 or 8, specific goals for every iteration. And a key part of that is delivered functionality that performs some function, even if you don't ultimately use it in the actual execution context, operational context. It's delivered functionality that does this much. And so demonstrably meeting the need is kind of the key part of that. So yes, if part of the work is you need to be able to have satisfaction, demonstrable satisfaction, the acceptance criteria. I know this is right, here, let me show you at the end of every iteration. And if I can't do that, then how do I know I did a good job, frankly? So yeah, so I do want to be able to demonstrate within that. So as part of chunking my projects, you have a kind of 3 or 4 levels of planning in Agile. The vision kind of planning, and you've got the then you've got the set of iterations you expect to perform. Then you've got an allocation of capabilities, user stories, epics, use cases, whatever, to these iterations. And then you've got iteration planning, where you go to the individual iteration, you say, okay, within this iteration, this is the detailed set of user stories or requirements or whatever I'm going to deliver. At the end of that iteration, I will have demonstrable value around those things that I'm including in the iteration. So that's exactly how I chunk it, yes.
Okay. I have a follow-up question to the one on stakeholders. If user stories relates to a subset of stakeholders requirements, and assuming that use cases relates to systems requirements, I wonder how we can maintain the classical hierarchy where system requirements drive from stakeholder requirements, which seems to contradict your hierarchy. Hierarchy where user stories are components of use cases.
Okay, so let me first of all state that use cases you can collect. Remember, I talked about the requirements classification. The same classification applies to use cases as well. So I can have stakeholder use cases. I can have system use cases. I can have subsystem use cases. So just because I'm a use case doesn't mean I'm focusing on system requirements. Okay, I can have system requirements, system use cases. I can also have corresponding stakeholder requirements. And it's pretty common that I'll have both. Depends on the environment. A lot of people just totally skip the stakeholder requirements altogether and just do system. Or they entirely skip the system requirements to stakeholder. A lot of people do that. But a lot of people do both. And that's perfectly reasonable to do. You have a stakeholder use case around some capability. And every one, and then so the stakeholder use case might trace to, say 30 stakeholder requirements. Then I've got a system requirement which corresponds to that capability, but it is now collects up 75 system requirements. And all the system requirements trace the corresponding stakeholder requirements. And that's a perfectly reasonable thing to do. If that
So let me ask a different question, a more implementation question. Bruce, have you ever considered or used a model pattern that says, hey, if I have a feature and I define a feature as a work item or an epic as a work item, this is the package structure and the tasks that I need to do. I either be a package for requirements, a package for stakeholders. Have you ever done or prescribed anything around those lines from an implementation perspective?
Yes. Oh, you want to know what it was? So I have a kind of standard form for system projects that I use for project structuring. So at the high level, I'll describe it real quickly. We've got a requirements package, requirements analysis package, and inside there, there's a package for requirements per se, which may be subdivided depending on how many requirements I have. And then I've got a use case package where I identify all the use cases, but they're all in the analysis, requirements analysis package. Then separately at the high level, I've got a functional analysis package. And inside there, I've got one nested package per use case. So if I've got 5 use cases identified, I have 5 sub packages where I do the function serves as a sandbox for functional analysis of that use case. So I've got a use case like I'll deliver oxygen, deliver gas flow, monitor patients. I've got different use cases. I've got a separate package per use case for the purpose of analysis of that use case. Then again, at the high level, I've got an architecture package, which has 2 sub packages, one for architectural analyses of various kinds, and another one for architectural design, where I have the architectural, the set of the system object block, as well as its part blocks, the subsystem blocks, and then the packages per subsystems. Then also at the high level, I've got an interfaces package where I talk about the interfaces either between the system and the actors or between the subsystems, as well as a data schema for those interfaces as well, because you're supporting flows, right? So that's all part of the interfaces package. And that's basically the standard form I use for this kind of project.
Okay. Do you talk about that in any of your books anywhere?
Yeah, it's in early chapter in the cookbook, for example. It's called the Canonical System Model Organization Form.
Okay, thanks. Anyone else have any other questions? Okay, thank you very much for your time, Bruce, and we look forward to hearing from you again on November 3rd.
All right, looking forward to it.
Thank you.
Thanks, everyone.
Thank you.